It was the summer of 2002. I'd been a professor at Dartmouth for not quite 10 years then, and I was twinking around with something in my laboratory when I sensed a student approach, and I could sense that the student was kind of shifting around uncomfortably a little bit, and look up, and the student says, "So, Matt, I'm really sorry, but I've got some bad news. We have a problem." Uh, so the student was Lindsay Reynolds. She was a Dartmouth rising senior at the time. I'd gotten to know Lindsay because she was a student in that winter in our tropical ecology course. And honestly, I'm still a little worried that she might be sore at me about the time that we drove off in the bus, leaving her at a fruit stand in the middle of nowhere, Costa Rica, but she's never shown evidence of that. Dick Holmes, Professor Dick Holmes, my longtime colleague and mentor, was another professor on the course, and Lindsay impressed both of us during the course and showed great enthusiasm for developing a project at Hubbard Brook. She ceaselessly extracted information and questions and thoughts from Dick and I while we were working together, and then came back and wrote a successful proposal for a very interesting research project that would be her senior honors thesis at Hubbard Brook. The organizing question, motivating question for the research was, why does the abundance of caterpillars vary so much among years at Hubbard Brook? We only knew this by virtue of work that Dick Holmes and his many students and colleagues over 20 plus years had obtained while doing standardized surveys of caterpillar abundance as part of their bird studies. Because in addition to other things that Lepidoptera do, of course, they serve as bird food too. So what those data showed is that the abundance of caterpillars per 2,000 leaves, say, or the biomass of caterpillars varies among years, even over just 20 or 25 years, by like 30-fold. Extraordinary variation in abundance. So Lindsay's research question was, why does caterpillar abundance vary so much among years? So she came at that with a set of multiple working hypotheses that she went on to test very effectively in her work. She tested for effects due to winter cold, summer warmth, predators, including both birds and invertebrate predators like parasitoid moths, and also phytochemistry, the chemistry of the foliage, the concentrations of protein or nitrogen in the leaves, and the concentrations of the bad stuff, the plant defenses, secondary metabolites. And so what we knew at that point is that the plant phytochemistry from year to year, even the same plant, can be affected by environmental conditions. So in conditions where it favors tree growth, there ends up being more growth, higher leaf protein, and lower secondary defenses. So potentially a good world for the caterpillars. In years when things limit growth more, tends to be less protein, more secondary defenses. So Lindsay came up with the idea of using tree cores to reconstruct the history of tree physiology. We didn't have historical records of leaf phytochemistry. That would have been real hard, but we could predict based on the growth differentiation balance hypothesis that years when the trees grew less should be years when the leaves would be less palatable. So she was out collecting, among other things, lots of tree cores. We use a tool like this and She took a boatload of tree cores, hundreds of them, and that's what she'd been doing that day. Uh, Her story was that, uh, Matt, I'm really sorry, but the tree core got stuck in the tree and I couldn't get it out. And I thought, well, this isn't so bad on the scale of such things. Don't worry about it. Well, the cores are finely machined steel. They're a few $100s. I thought, well, that's a little bit of a bite, but that's no big deal. But then later I'm thinking, God, what if someone I know walks past that tree and sees a drill bit sticking out of it and laughs at me? Of course, that's what they do. That's what I'd do. And so next morning, I got up and drove to Hubbard Brook, and I thought, well, let me see if I can get the core out of the tree, or at least I can tell Lindsay that I tried to and I couldn't get it out, or at least make sure it was in a place where no one was going to see it. Well, it was the opposite of the latter. It was a worst case scenario. The tree was right across Weir 6, and right on the trail that the birders go through every day. And what had happened is that the tree, it was a sugar maple, had a rotten core. You couldn't tell it from the outside. And so she's pushing, drilling. It breaks through. And then these drill bits, they're not machined to drill back out, nor is the tool designed for that. So it was a hard situation. I thought, how am I going to get this out? Do I have to? I absolutely have to. Otherwise, for years, uh, there's going to be birders walking past here chortling about me as they point to the drill bit. And a part of this story is that this was one of my first entries into research leading a project at Hubbard Brook, and I really wanted it to go well. I particularly wanted it to, look good for, my friend and mentor and hero, Professor Holmes. And since I've been 10 years old, I've had avian ecology envy. And so I thought maybe if we do well on this, maybe those people will let me do more work on birds at Hubbard Brook. So I then had the image of, Dick Holmes walking past that tree every day for the next 100 years, raising his left eyebrow as he walks past it. So that I've got to get this out of there. So fortunately, I do work with insects that live in the bark and wood of trees. So in my pickup truck, I actually had quite a few tools that I could potentially bring to bear. Of course, we've got knives of all different kinds, bigger knives, smaller knives. We've got, little hatchets, bigger hatchets, axes. Let's see here. Oh yeah, little saws, big saws. Let's see, and here's one probably a lot of you don't know. We call this a bark spud. It's just perfect for knocking the loosening bark off of trees that have died recently. So you can see the inside and the insects that are there. And extra credit for anyone who knows what that tool is. Almost none of you have ever seen that tool before, I'll bet. Well, of course I had a chainsaw too, but that was pretty deep into the decision tree at that point. But what I finally ended up with was a chisel and a hammer. And so I found out why my dad used to call sugar maples rock maples. And it took hours. It took a little longer than it might have because I was trying to shape the hole and the wood chips so that to a casual birder, it might look like something that pileated woodpeckers had done. And then I was also very cognizant that the bird crew was likely to come walking back out after their, 7-hour day was done at any time. So I had to stop every few whacks and listen. And in fact, they did come out, but I was on to them before they got there, and I was studiously examining some hobblebush leaves for caterpillars or something while they walked past. So I eventually got the damn drill bit out of the tree. Neither the drill bit nor the chisel will ever be the same. There was some metal on metal contact along the way, but I did, and actually I've never heard anyone mention that since then. So maybe the pileated woodpecker trick worked out. So Lindsay went on to publish that work in Canadian Journal of Forest Research, a paper that we and others are still citing and building on. She went on to do a PhD. She's now a riparian ecologist with the Bureau of Land Management based in Fort Collins, Colorado. And I think she would have been here tonight, except she's out someplace studying riparian ecology. So that's the story. Thanks.